Hey, I am Micaiah, co-founder of TXTX, and at TXTX we're trying to make tooling that makes deploying contracts much easier. We want users to be able to describe what they want done on chain rather than how, like currently is needed with the Bash scripts or JavaScript files for deployments, or even the Foundry scripts. There's a lot of logic involved in deployments today, and TXTX just removes the need for a lot of that and makes things a lot simpler. So we have made runbooks, is what we're calling these deployment manifests. This runbook, we've made a runbook for the Farcaster contract deployments, and I wanted to just to give a tour of what that looks like and how to use it. So first, to install TXTX, we are on Snapcraft if you're using Linux, so you can do sudo snap install TXTX. Or if you are on Mac OS, you can do brew tap txtx/txtx. And then brew install TXTX. So we've installed TXTX. The first command we can do is just TXTX ls. This is going to list the runbooks that are being managed by your manifest. The manifest here, it's the txtx.yaml. We can take a look at this. Some things for now. So first we've got the name of the runbook and the name of your protocol. We have a list of runbooks here. So the name of the runbook, an ID, a description, and then the location of where the files are. That's repeated for each of these runbooks. Some of these have state that we'll get into, but this is just a location for the state file. And some of them don't have a state at all, so there's no location for the state file. And then we also have some environment variables, so we can create any set of environments that we want to, and then whenever we're actually running it, we would just pass in the env devnet or whatever we name our environments. And so we can set up some constants here as environment variables. And so when we ran txtx ls, we see these are the runbooks that we have managed by our protocol. I will give a quick tour of the DeployL1 runbook so you can see how this works, and then we can go through, this one's much simpler, and then I'll go even quicker through the L2 deployment. But essentially, this is what's going to cover our whole deployment. So we're declaring an add-on called EVM. TXTX actually works with multiple blockchains. So here we're saying we're using the EVM add-on, and then we're defining some default values. So any of the actions we want to take, we'll need to know what the chain ID is and the RPC URL. Rather than having to specify it in each action, we can just specify it once in this add-on block, and it's going to be applied to all of the downstream actions. So we're saying input.l1 chain ID. These inputs are what's defined here. So we have an L1 chain ID and an L1 RPC URL. And so we can just reference those here, input dot those values. We can declare a signer. So here we're declaring a signer. We're naming it. This is like a variable name deployer. And then we have these different types of signers. Here we're using the EVM secret key signer, and we're just pulling the secret key from our manifest. And then what we're actually wanting to do is deploy a contract. So we can use the EVM deploy contract create to action. We also have one that's without create to. That'll just use your nonce, but with this we can use assault. And so we have if we're doing multi-chain deployments, we have a consistent address across chains. And so we have the contract we want to deploy. We can just use this function, EVM get contract from Foundry project, and it's going to be able to you pass in the name, and we can kind of parse out from the Foundry project the contract that you're deploying here. We can pass in some constructor arguments. So we've got the resolver URL, that's one of our inputs, and then we have some additional addresses, and we're just encoding them as addresses with this function. And then the salt we want to use, all of this stuff is defined in our manifest. If I remove this, by default, our create2 contract deployment, it's going to use the same factory that Foundry uses by default. So if we want to specify some alternate factory, we can provide the address here, the function name we're calling. So this is the safe create2, and then the ABI of that. And finally, we can say who's signing the deployment. We can just reference our signer. And then we can also output some data. So like we can say we're going to output, the value will be action.deploy fname resolver. So that's the action we just created, and then the resultant contract address. One thing that's cool about this, with your existing scripts, if we look at the DeployL1 script that you have, you're having to implement this immutable create2 deployer, where there's like some logic that you're having to manage here, where you register the contract, and then you deploy it. And so then you're having to, so you call register, then you call deploy. And then later on, when we get to things like the DeployL2 one, we're having to check to see if one of them was actually deployed before we do some subsequent actions. Txtx will actually just manage the state of this for you. We keep a state of all of your deployments. So we don't have to do like the register function first. We can just go ahead and just go straight to safe create2, because if we do this deployment and then we run it again, it's actually going to have no action. We'll see that we've already done this deployment, so there's nothing to do, and you don't really have to worry about accidentally redeploying. So we can just directly call the safe create2 function here. And so if we want to, actually, real quick, I went through all these constructs. I will note docs.txtx.sh. If you go to the left, there's integrations, EVM, and then we have these functions that I use. So like I use the address function to encode as an address. We have documentation on all of this stuff. Get contract from Foundry project. We also have get contract from Hard Hat project. The signers, we used a secret key signer. We'll jump into the web wallet signer later. And then all these actions. And so, we have documentation on all of this if you want more information with examples as well of all of this. But to actually run this, so we're looking at the DeployL1 script. So txtx run, DeployL1. I'll pass in the environment, devnet, and I'll say -u unsupervised mode. This is just gonna, like, in the CLI, just run everything. We'll get into the supervised mode later. So just run this. We don't have a state file that exists currently, so it's saying don't have that yet, but now we're sending transactions. Okay, so we've deployed the contract, we see the address, and now we have this state file saved here. So if I do txtx check DeployL1, we can see there's no actions to make. There's no actions to be run here. We're in sync because we haven't changed anything in our contracts. But if I try and run it again, I'll get the same thing. So like if you haven't changed any of these inputs, or you haven't changed your contract, there's no actions to run. We're managing the state, so we can just like prevent you from accidentally redeploying things and wasting gas. But if we want to change the contract, so let's for example, let's open up fname resolver. I'm just going to version this, do a forge build. Okay, so now if I do a check, we'll see we have new bytecode, and this is the actual summary of what's changed. This is going to introduce breaking changes. So we can see that if we do the run, we can see what actions are going to be rerun. So because we changed the underlying code here, this deployment will need to be rerun, and because this deployment is rerun, downstream actions will also need to be re-executed, like outputting the address. So we have a graph of your entire execution, and we can see downstream everything that needs to change, and you can say yes or no. Okay, so we'll redeploy this. And so we've got our new address. And once again, if we run this, we'll see there's no changes that have been made. I'll quickly go through the L2 deployments. Maybe this gets a bit more interesting. So if we look at this one, so first of all, same thing, declaring the EVM add-on. We're referencing or setting up the chain ID, RPC URL. We're doing a lot of deployments using the same immutable create to factory. So rather than setting this up in each of these deploy contract create to actions, we can just do it once at the top. So it's just for your convenience, you can declare it in the add-on, and now all of these deploy contract create to actions will just use this by default. Setting up our signer, and so now we're going to be deploying a lot of contracts here. So yeah, get the storage registry contract, set up all of the constructor arguments here, passing in all the addresses. Here I'm referencing a variable. Just for organization, I put this in the variables file. You could put it right in here if you wanted to, but if we look at the variables file, we'll see declaring a variable with a name. We can give it a description, a default value. Later on, when we get to the supervised mode, I could say editable equals true, and live you could like put into an input field what you want the value to be, so you could kind of update these and tweak them before actually executing. Here we go. But so we're referencing those variables that we've set up. So yeah, we've got this one, the deployment set up. Now we're doing the ID registry contract. And so we deploy that one, pretty straightforward. Now when we get to the ID gateway contract, we'll see that the deployment needs to reference the previous action. So we need the ID registry and storage registry contract addresses, so we can just say action dot the name of that action dot contract address, and we can set up those constructor arguments for you pretty easily that way. So yeah, we're going through deploying all of these contracts, and then we get into the post-deployment setup. Again, if we look at your current scripts for the deploying L2, we have this run setup function that we only do if you have this if deployment changed, where your immutable create to deployer is tracking which, like, if a contract is deployed. We don't have to do any of that with TXTX because we're managing the state. We can tell if something's changed, and then this whole thing will be re-executed if it's changed. And we could get more granular if we wanted to. We only have the downstream actions of the contracts that have changed to actually be re-executed. So we'll demo that here in a second, but this time we're using the call contract action. And so we can reference like the ID registry contract, what we want to call. We can reference the ABI, and that lets us just use the function name directly. We don't have to pass the 4-byte signature. We can just pass the actual function name, as well as it gives us type checking on these arguments. So yeah, we're calling set ID gateway, we're transferring ownership, we are setting the validator, key gateway, we're doing all of those, granting the roles, all of that stuff that we do in the L2 script, we can do here. So yeah, let's do ls, we got the ID here, so txtx run deploy L2 this time, devnet unsupervised. So we're going to have a few deployments to do here. So we'll see a few blocks being mined. We're automatically creating this graph of the order of execution. So because, for example, the ID gateway references these two constructs, these will always be executed first. And if you wanted to wait wanted to wait 5 blocks, you can do confirmations equals 5, and then downstream actions won't happen until 5 blocks have been mined. By default, if you just leave this out, It's one confirmation. So we're always keeping this ordered set of executions here. So here we have the all these transactions that were executed and the addresses of the contracts we've deployed. Now, if we run this again, we'll see latest snapshot in sync with runbook update. So there's no changes here to execute. So once again, we're not going to do we're not going to redeploy it unless there are actual changes. Because we have this set of dependencies in the contracts, it gets a bit more interesting if we make a contract change. So for example, let's look at the ID gateway. It's kind of in the middle of this set of executions. So like if we change this, well, we don't need to redeploy either of these. They are unimpacted. And we won't need to do the key registry or the key gateway, but the bundler needs to be redeployed, and we have some contract calls that are going to be affected here. So if I go to the ID gateway contract and I increment the version here for Jill. So now if I run this deployment again, we can see the diff and we can see the exact constructs that will be rerun. So transferring the ID gateway ownership is impacted by this. We are outputting the ID gateway address. So we're going to have a new address here, same as the bundler address. We're going to have to grant the operator role. So let's take a look. Okay, ID gateway. The grant operator role. It has the bundler address in there. The bundler deployment is being updated, and so we're going to have to re-execute that. Deploying the ID gateway, setting the ID gateway. So yeah, we're detecting all of the downstream actions from that one contract change, and so only those actions will be re-executed here. So I press yes, and we're going to send those transactions. And again, so it's just when you version your contracts, we are kind of managing all of that dependency flow for you. So only the necessary contract calls and contract deployments are run again. While those are running, another cool thing we can do here is we have one more run book. So we've got these two run books that are like our deployments. TXTX is great for operations as well. Specifically those that maybe you don't want to be using a secret key wallet where you have to have your secret key somewhere stored in a file. This is, okay, we can see those contract addresses were deployed. Just those two are output. So this grant role runbook is doing a contract call of the storage registry contract. We're calling grant role, and we're passing in these values. So if we look at these values, we are doing, bytes 32 of the catch-act function of this role, which is a variable. We have a default value, but it's also editable when we run in the supervisor mode. And then we're also passing in the address where we have a default value, but the user can update it, the operator of this runbook. We're outputting the transaction hash, so we're gonna call this grant role function, and then we're just calculating based off of the current file structure, like what your contracts have and these inputs. We're just calculating what the create2 address could be. You could reference a constant if you want to like hard code it to an address that you're calling. You could make it an editable field like this one. Here, just to make things easy for you, we're just calculating based off of the the storage registry contract that we're registering here, referencing here. So we can run txtx run grant role --env devnet, and then we'll leave off the -u, that unsupervised mode. We're just going to run it like this. We have a localhost little web app here, so we can validate. So this is the wallet I have connected, and then we check. Okay, that's the address you set in the runbook that you expect to connect. We can see the balance to make sure it's enough to do this deployment. We can see all of the parameters that we're calling this contract, and with these values to generate the contract address. Here we have these editable fields. So instead of the operator role, let's do the owner role. So you can just change that live here. We'll leave the address as is. We can see the address that was generated. Now we can see the account nonce and the cost of the transaction. And then we can actually send it, and we can sign and send directly via MetaMask here, validate. Now we can just wait for that to be mined. And so now we haven't had to use our secret key anywhere. We have done this contract call just directly by signing in the browser. You can do any of your deployments that way. You just change the signer type. Instead of doing EVM secret key, you just do EVM web wallet, and now you can use the supervisor mode to sign your transactions. So we hope this is helpful for you guys. We have so many ideas for features that we want to add to TXTX to make it easier and safer to do all of your contract deployments and operations. We're looking for teams to start using it, giving us feedback on stuff they'd like to see added. So if you guys are interested in using this tool, we would be super excited and grateful to work with you. So yeah, thank you for your time.